Uh, Colleagues, I do apologize. I said 17:45 here. This is this is 17:52. I literally had to run away from my previous meeting. Sadly, one of those project meetings, and I had to run away from meeting I was attending here. But I was telling my colleagues I was with that we this is supposed to be the last week of classes at the University of Zambia, and so I can't afford to miss this session here. And this is the thing here. Right? It brings us to the issue of time here. This semester has been, or this term really has been a horrible term, right? A horrible term. First, if you remember our discussion of what do you call this? If you remember our discussion of the administrivia, right? The session dates. The University of Zambia, in terms of session dates, they call them terms, right? They call them terms here, but there are two terms, so not as well call them like semesters or something. But in the classical sense, that they are really terms, really. The terms at UNZA are ideally supposed to be 15 weeks, right? Each. But because the UNZA has been working towards trying to streamline or to align their the session dates with the regional session dates, what they're doing is they're eating into potentially time that we should have been allocated, like this year and last year actually. So I believe last year and this year these things have been trimmed down to 12 weeks instead of 15 weeks, right? So we had about 12 weeks to work with. That's the other thing. Unfortunately, we lost a week, because of sanitation challenges at the UNZA, students ran amok and all those things. And we actually started this term late, primarily because we have a number of new programs introduced, and unfortunately, in a significant number of those programs have certain courses, right, as either core courses or electives, as it were. And this is a classic example, right? CSC 5741, So it's a bit tricky here. And I say all of this here because, technically speaking, I'm sorry, I have to showcase these things here in case colleagues have forgotten here. If you look at our session dates, right, ideally we're supposed to conclude all classes this week, so on the 17th, okay? And there's a bit of mayhem here, chaos, by the way. So we're supposed to conclude this because it turns out that what is supposed to happen next week is you're supposed to start preparing for exams. In fact, by the end of this week, you should receive a draft timetable indicating exactly when you're going to be writing exams in the various courses, right, where applicable, okay? But perhaps what's important here is that the examination period is supposed to run from the 27th of April all the way up to the 11th of May, right? So in essence, exams begin after next week, okay? So it's likely that this course will actually be administered either on the 27th, 28th, 29th, or the 30th, because the first is a holiday ideally, okay? And so because of this, I've had to make some radical changes. So there are certain topics that we're supposed to kind of like cover or look at that we're going to cruise through, unfortunately, especially the ones to do with implementation. What I'm going to do is I'm going to focus on evaluation. If there's any consolation, especially for people that are doing AI and I think IT, probably IS as well, you have that course that is tagged as, I think, advanced machine learning or something. You can take as an option. It turns out that for these other programs like IT and IS, they are structured in such a way that the courses that you are borrowing from elsewhere are going to create some kind of career path, right? So the onus is on you to try and build, I guess, expertise in a preferred stream, if you will. So those of you that are attending this course, I imagine, are probably interested in things to do with data analysis and perhaps some AI or machine learning or something like that, right? So that's the first thing I wanted to mention. The other thing I wanted to mention is that because we are somewhat behind here, the thing that was supposed to be a mini project, what I've done is I've made slight adjustments, right? So we're going to convert this into some kind of presentation, right? Like a proposal presentation. Okay, so what I'm going to do by tonight after class here, I've already prepared a series of questions, but I want to run you through this, is I'm going to provide you with predefined questions. Your task is actually to choose a question that you want to work on. These are going to be left open-ended by design. And then I'm going to give you a couple of days to think about a potential solution to that problem. So you're going to craft the problem, you're going to carve out the problem to this topic that I'm going to provide, a chosen topic. So you carve out a problem and then you come up with a proposed solution. So more or less like a mini project that is aimed at you coming up with a proposal, if you will, right? A proposal to the problem itself. And what I want to suggest is that I give you about 7 days a week. So on Wednesday, right? Wednesday next week, we're going to take turns and mimic what we do when we transition to part 2, where we're given X number of minutes to do a presentation, and then there'll be like a Q&A or something based on your proposed solution, if you will. Okay, so my expectation really, and this will be provided in the specification for this mini project, the expectation is going to be simple. You're coming together with a proposal. I'm not interested in the document, but I'm interested in the presentation itself. So you're going to tell us, all of us will be in attendance, and you're going to tell us exactly how you go about attempting the problem itself. By following through with what we introduced as the data mining and knowledge discovery pipeline or process, right? And we expect you to use the CRISP-DM methodology. So that's the first, the second announcement. The other thing that I wanted to mention, something that I already shared in the group, is that the test, I really remember mentioning that potentially we can have the test today or something, but my suggestion is that we just finish off whatever we can in the time that is remaining, and then either on Sunday or Monday we can have a test. And the reminder here that we agreed in the most recent class that we had that the test is only going to go as far as this, is it? This is what we agreed. What we covered last time when we met. That's it. Okay? Everything else we are covering, like the stuff we're going to look at today and possibly on Saturday or something, is not going to be in the test, but will be in the exam. So it should be a fairly easy test because the coverage really is not that extensive, right? So coverage for test, class theory test is, again, as mentioned last time, is only going to be as far as our discussion of module number 4, which is data cleaning and text preprocessing. I don't know if you've already set up a poll, but I had a suggestion to say, maybe you put up a poll, because I noticed people were responding to my message, and almost everybody who had responded, about 3 people, are suggesting that we have this test on Monday. We can have it on Monday, but the other option that is there is Sunday. I will block off my Sunday such that I'm available between 12 and 17, in fact between 12 and 18. Okay, so if the vast majority of class would want us to have the test on Sunday, that's an option. This is an in-person test. You must show up. You must show up at the department ideally. Okay. The other option is we have this test on Monday. If we have it on Monday, we're going to have it at the same time as my programming for data science class. I teach a programming for data science course, which is it's a core course for the Master of Computing in Data Science program that we've introduced this year. So with that said, I know probably you will have a discussion as a class or something in your WhatsApp group or wherever. You must just let me know if it's Sunday. This is going to be a very easy test here, just 1 hour, right? I just need 1 hour of your time, which is why I left it open-ended on Sunday. So if we are to have it on Sunday, we can have it either between, if it's Sunday, we can have this between 12 hours and 13 hours, right? You know the drill here. Or 13 hours to 14 hours, or 14 hours to 15 hours, or 15 hours to 16 hours, or 16 hours to 17 hours, or 17 hours to 18 hours. I'll be at the department. If it's Monday, on Monday, we are starting at exactly 17:30 together with the other group, and then we'll stop at 18:30. Okay. So please do let me know what you decide as a group. If you have any challenges in terms of availability on Sunday or on Monday, it is important that you send me a formal email. I know somebody, our colleague, Mr. Sakala, Ernest, sent me an email. I don't know if, because he was anticipating that would have our assessment today. If he's still unavailable, it's not an issue. Organizing a makeup is not an issue. This we can do, but there's only so much we can do, right? We can only administer these makeups only before the 24th, ideally, because we can't do this during exam time. So what I'm saying is, if you're not available, if we decide to have our test on the 19th and you're not available, you can just write to me and tell me, just provide the reason, I'm going to be out on work duties or something like that, or I'm sick, or I'm attending something, right? All those reasons are valid. And then what I can do is I'll find a day, right? Either on the 21st, 22nd, 23rd, 24th, in fact, I can even extend this Saturday, 25th, or in fact, even the 26th, to organize a makeup session for those that will not be available. Okay? All right, with that being said, and usually this makeup is completely different from the deferred, actually not makeup, it's a deferred assessment. It's usually completely different from the one. I don't have any questions or thoughts about this. Yes, please.
The test, will it be physical or online?
No, test, it can't be online because we'll be fooling ourselves, right? We know people will just go on ChatGPT and stuff. This would be an in-person assessment. I mean, we might as well not give you a test if we say it's going to be online, right? It's like, what are we doing here? Nothing. In fact, this is the reason why I'm even saying that in terms of this mini project, right? I could have said you just produce a report, right? But I know what's going to happen. So for us, what is going to be an objective way of assessing whether or not you've actually grasped some of these concepts we've introduced is when you're presenting. Now, the presentation can be online, but please be prepared. You switch on your camera or something. I don't know if you guys have seen some of these exams, right? Where some students, maybe they were not actually reprimanded during the public defense, but you could see, right? Somebody switches on their camera. I think most when they were responding to examiners' questions, you can see that somebody is reading from somewhere, right? Even if you've been doing this work for the last 2 years, or 1 year plus or something, you should own this work. You shouldn't have to refer to notes. Okay? So the test is going to be in person. Okay? Which is why maybe Sunday would be ideal, because most of you are probably not going to be working. I tried as much as possible to avoid the Saturday because I know that our colleagues that are Seventh-day Adventists are very particular about the Sabbath. So I in as much as UNZA is quote unquote, I guess, arguably a secular kind of institution, I usually try to avoid having these important activities later during the day on Fridays, on Saturdays. But on Sundays as well, I'll typically organize these things like in the afternoon, right? When I know most people that maybe belong to these Protestant churches here would have probably gone to church and then would have come back. There's another hand up. I don't know. I thought I saw a hand up.
I wanted. You mentioned that the test will be based on lecture 4. So is it from lecture 1 to 4 or just lecture 4?
No, I said the test is going to be based on everything we have covered until lecture 4. So 1, 2, 3, 4. Technically speaking, it's actually 2, 3, 4 because 1 was admin trivia. I mean, there is some stuff in there, like when I was contextualizing the course, but 1 to 4.
Thank you.
Okay. Any other thoughts or questions about this? Yeah. No.
Yes, you did mention in the group that you are going to show us a sample of questions of the exam.
Yeah. So what I will do is, instead of wasting time showing you the samples, what I shall do is, in fact, I can do this right now if I haven't done this already. I think I may have done this already. But if I haven't, I don't know if you can see my screen here. I will go to the Google Classroom site. I guess I can do that. I don't know.
Can see it.
I'll go to the Google Classroom site and I will make available. I think I did. If I didn't, I do apologize. I'll just make available all past tests, right, from as far back as 2019 when I started teaching this course. Okay, so under classwork, you will find a section that will be tagged as past assessments, which is this. Okay. I haven't. And in here, what I will do is I'll actually add even last year's assessment here. I need this to be, it's not supposed to be this here, course assessment. I'll go to class theory tests. Currently have, I think, about 2 of them, 2 samples, but I'll add last year's, right? This is from 2020, 2021, I'll add 2022, 2023, 2024, and last year, 2025. So it should be sufficient. So if you look at all of these sample tests, I'll even throw in these exams, right? If you look at these past assessments, you have an idea of, what do you call this? The way these questions are going to be asked, right? Somebody was asking, are they going to be multiple choice questions? And I said no, right? So it would be something like this. You were given a bit of context. I like, because of the nature of the course anyway, I'll typically give you a scenario, right? Like in this particular case, I give you a scenario and some sample data set, and then I have a series of questions, right? A series of questions. Some of them have a little bit of programming to them, but at this level of study, the interest, in fact, for most advanced degrees, right? Unless if it's a programming-centric course, the obsession is usually on high order thinking, is it? So the abstract stuff that we've been looking at. So at your own time, if you have questions once you go through these samples, I've shared them, you can shoot me a question. Is that fine? These are the samples. Okay. Don't know if there are any other, kind of like thoughts or questions about this. Okay. Now, colleagues, if there aren't, what I'm going to do is, because we still have a little bit of content to cover here, I'm going to suggest 2 things here. I will focus a bit more on the theory, and then I will share notebooks. But where I feel it is necessary, I'll do what I've been doing, where I'll context switch and then just kind of showcase a few things. But what I have done is I have shared, or I shall share, companion notebooks. And these companion notebooks actually build upon this example that I've been obsessing about from the outset, right? Students at risk of failing, so that it's a lot easier for you to understand, right? The terminologies and all those things. So what I shall do at a later stage, in fact, as I'm uploading these notes, is I shall share these notebooks here, right? Easy to follow, they are well documented. I pride myself on making sure that I do those things. I do those things quite diligently here. Okay. So with that being said, I guess we can proceed, right? So today we are building up on what we were discussing last time. If you remember, we spent quite a bit of time.
Sorry, Doc.
Yes.
The slide decks, I notice we only have 1 to 3 on the classroom.
Oh. I will upload four and the current one 5 then. I'm gonna refrain from uploading 6 because I will remove some of the things that I normally cover because of timing constraints. So thank you for that. I will upload the lecture series number 4. Thank you very much.
Thanks.
Yes, more questions?
Yes, I wanted to find out, since we have new CS accounts, can you share the class codes that we can join with the new IDs?
So sorry, can we what?
The class code, the Google class code.
Oh yeah, sure. I will share this.
We can.
Yes, I will. I guess I can share it right now, but I will share the thing. The only issue is that I don't know if you were around when this is 4. I don't know if you were around when we were having our Administrivia discussion, but it turns out that I created this Google. It's complex, really. I created this Google Classroom site, and I have my own reasons why I do this, right? I created this using my UNZA, not my CS account, right? So unless if Mr. Benaya Kombo has fixed this issue, one of the things I noticed is that if we attempt to add a person using their CS account, it kind of like fails, right? You know, it fails. And I think there are some of you that had attempted to do this, those of you that had CS accounts before, like if you did your undergrad at UNS or something like that. And I know it sounds confusing because in these other courses you're able to use your CS accounts, and the reason is because in these other courses the course instructors have created the Google Classrooms using the .cs domain, so they've used this, right? They've used this, and I personally use this, or I use this because I know that I have control over personal email addresses, so students can enroll using their personal Gmail accounts without a problem. But if you try this with your CS account, with the CS, with a Google site, a Google Classroom site that has been created with a CS account, you notice that you get errors. It's complex, I know, but that's the way it is. So we can do a short test here. I will share the invitation link again just now, and then you guys can attempt to see if, by the way, I've added lecture series number 4 here. You guys can check to see if you will be able to access you'll be able to access this site. Okay, this site here. I'm going to share the invitation link. I suspect you won't actually. I'm not trying to be a prophet of doom here, but I suspect this will not be possible. There we go. I see there's a hand up. Looks like there's going to be a lot of questions today.
Yeah, have we finalized for the test for Sunday?
No, I've left it to you to decide as a group. I don't know what you decide. I'll personally be available. I'm available both Sunday and Monday. But in my opinion, if you do this by Sunday, it leaves you a little bit of time to prepare for the other assessment, which shouldn't be really that hard, right? Just putting together a presentation slide deck and preparing for it. So we haven't settled for a date. I don't want to impose. I've left it open for you to decide as a team, as a group, on whether you want the test to be administered on Sunday, either at 13 hours, 14 hours, 15 hours, 16 hours, 17 hours, or on Monday between 17:30 and 18:30. I don't know. I suggested that you set up a poll because people are just sending what do you call this? They were just responding to my message. Yeah. All right. Any other thoughts or questions about this, colleagues? Okay. If not, I'm just curious. If you notice here, look at this. Emails must be within your domain or admin approved domains or something like that. So I don't know if this will work here. Maybe the invitation will come through. I don't know. But you can try it out. I've sent the invitation link. Okay. Now, I imagine there are no questions here. You remember something, right? When we had our interaction a couple of days ago, we actually said that we'll double back and start looking at these individual phases of the CRISP DM methodology, right? Yes, we know there are a number of different options available to us. SEMA, KDD. We can come up with our own custom methodology to use, but we said that we're gravitating more towards the CRISP DM methodology because it's actually domain agnostic and it's implementation agnostic as well. But more importantly, we realize that this CRISP DM methodology has 6 phases. And so what we did last time is we went back and we reminded ourselves that the first 2 phases here, business understanding and data understanding, we don't really care so much about them, right? Because, if we're experts in computing, we know exactly how to do this. When you look at business understanding, all you're doing really is you're listing requirements, right? If you remember, situation analysis and all those things. And then for data understanding, most of what we are doing is we're trying to figure out exactly how we're going to collect this data. Now, the process of collecting data is beyond the scope of this course. I would like to think there are those of you that are going to be doing, is it a dedicated NLP course next term or something? In that course, one of the things you're going to be doing is learning about different techniques that you use to actually extract or collect data, right? So packages or libraries for scraping data from web pages, right? Like Beautiful Soup, for instance, or packages that you can use to actually extract data from APIs and all those things, right? But so we don't really care so much because in some instances, actually, you already know how to extract the data. Like for instance, if the data is in a relational database management system, you know that what you can do is you can take advantage of pandas, right? And we had a discussion about this. You take advantage of pandas, and what you do is you take advantage of pandas by using this, right? PD dot, if you remember this, dot read. So if you're pulling data from a database, all you'd be doing is either using this or this, right? And stuff like that. Right, so this is trivial. Step 1 and 2 really are trivial, right? At least the part to do with data collection. But a reminder here that we mentioned that there's an important exercise, an important operational activity that you perform as part of both data understanding and data preparation, right? So this idea that you would want to inspect the data that you're working with, right? So you've collected the data. Before you actually even start pre-processing the data, we discovered that there are certain things that you ideally are expected to do. Like, for instance, check for outliers, right? Like, for instance, try and check the proportion of data attributes that have null values, okay? So we said that you do this as part of data understanding after you collect the data, but also as part of data preparation, right? And everything we are doing as part of doing all these different activities here is centered around this notion that we want to ascertain the quality of data that we're working with, right? If the quality of data is horrible and we can't fix the anomalies with the data by imputing values, for instance, and excluding certain observations, then what we do is we abandon ship, is it? We either find a different source of data or we abandon the data mining project altogether. And of course, you can create synthetic data, but that's neither here nor there. And it turns out that this exercise is typically best done, we mentioned this, by using visual techniques, right? So techniques that make it a lot easier for you to analyze huge quantities of data. If you're working with 230 students, for instance, you can get away by analyzing this data, using some spreadsheets or something like that, right? Although that would be counterproductive here. But what is usually useful is you utilizing visualizations, right? Or techniques that will enable you to summarize data. And it turns out that this process has a name in data mining. It's called Exploratory Data Analysis, or EDA, right? So this EDA exercise will enable you to derive insights from data sets that you have identified as being potential inputs to your data mining pipeline. And again, you ideally perform this EDA process or this EDA exercise as part of data understanding, phase number 2, and also as part of data preparation, which is phase number 2. It's the same thing. You are visualizing your data, you're analyzing your data, but you do it typical on those 2 phases. Okay? And it turns out really that, again, EDA is there to help you find insights from your data or your data sources. And it turns out that it's a very, very useful exercise as it sets the stage for what we were discussing last time, which is data cleaning or data preparation, pre-processing. A reminder again that data cleaning or data preparation actually is associated with phase number 3. It's almost like we've gone back here. I didn't want us to start talking about EDA before we looked at data pre-processing, but that's neither here nor there. Okay, so again, the output of your EDA exercise is used as input, is it, to the next phase here. So let's just think about the EDA exercise, your activity as it relates to data preparation. When you're conducting the EDA process here, the output is going to be used as input to the modeling process. Okay? And by convention, usually what most people do in practice is they will perform the EDA process as part of data understanding and then also as part of data preparation. In all these different instances, you are analyzing your data. But you begin to notice here that the analysis of the data is done for different reasons. Like when you're doing your EDA process as part of data understanding here, you're trying to decide on whether the sources of data are appropriate for a problem or for a solution. Okay? So you do your initial data collection and then you visualize the data. And you notice, we see here that a significant number of observations have missing values for the title, for instance. And you decide, let's just look for another source. Okay? And then we see here that when you're performing this EDA exercise as part of data preparation, some of the interesting things that you're doing here is you are deciding which attributes to include in the modeling process. Once you harvest the data, it's not always the case that you would you would actually include all the data attributes, right, as you're implementing the model. Okay, so that's one way of doing it. The other reason why you may want to visualize the data as part of data preparation here is identification of outliers, is it? It's a nice way of identifying outliers, right? When you visualize data, like if you say you have scores of students, for instance, you can draw a histogram, right? And that histogram is going to give you a sense of which data points are actually outliers. So those things that will be on the either extreme, the tails, is it, of your bell curve, right? If you remember your statistics here. So ideally, you visualize your data and you realize that maybe the data is like this, is it? Your data, once plotted on a histogram, these are scores, right? It's like this, right? You have a lot of students, maybe this is somewhere around 70 or something. You have the majority of the students that got 70 in that assessment, but there's still some here that kind of like failed, right? We'd say these are outliers. Like if a student is getting 1 out of 100, for instance, that's an outlier, right? Also, freaks of nature, I guess, those that will be getting 100 out of 100 or something. So you make a decision on whether to remove those outliers. The key thing here is that when you take advantage of your so-called exploratory data analysis, you'll be able to identify these things easily. This is, by the way, when you're dealing with continuous data, right? Because you wouldn't want to draw a histogram when you're dealing with categorical data, like dichotomous attributes such as gender, right? Male or female. Like, how are you going to draw a histogram, right? Anyhow, as neither here nor there, right? I went ahead of myself here. Okay, now it turns out here that there are various techniques that are employed during your so-called exploratory data analysis. But a reminder that the goal for all of these different techniques is actually to gain comprehensive insights into your data set, to identify the important attributes, data attributes, right? To identify important data characteristics. And to identify things like outliers or anomalies, right? Things that don't make sense, you know? Because when you incorporate the things that don't make sense into the model that you're implementing, the model implementation process, you end up with a model that is not going to be as effective as expected or as anticipated. But also, you may be interested in determining correlations and various data characteristics associated with what you're doing. Now, in terms of the key outcomes of the EDA process, after you're done with the EDA process, you will be able to identify important data attributes. Right? Should I include what do you call this? Nationality when I'm implementing my model, my inference model? Probably not, because almost all the students are Zambians, right? You have like a few international students, quite all right, but if all of the students are Zambians, then what exactly is the point of including, and I wanted to context switch here, but in the interest of time here, what would be the point of including other nationalities, right? So you drop that field, is it? What you're doing is you're identifying important data attributes. You begin to notice, right, this particular example I'm giving here is actually applicable to the EDA exercise as it is performed during data preparation, is it? Because you're identifying important attributes as you are wanting to implement the model. Okay? What other outcome? You will be able to determine those different attribute types or the data characteristics, right? Associated with your data set. And this makes sense, right? Because if you remember our discussion, when we had class last time, we realized that when you're working with a data set, and I want to context switch here, I'm tempted, colleagues. When you're working with a data set, I don't know if I have it here. Maybe I do, maybe I don't. I don't know if it's in, wow, it's not here. Data set. Look at data set. I don't know, grep CSV. I thought I had it somewhere. I thought I did, maybe I didn't or something. I really wanted to use the students at risk of failing data set. I like using that a lot because unlike the DSpace one, it has quite a number of attributes, right? A lot of attributes actually, which is usually quite nice here. Colleagues, apologies, I need to context switch here because I think I will need that thing as we are doing this. I'm just looking for CGIR and it appears I won't be able to find it. Wow, this is SIG CSC or something. It's not here. Maybe it's here. This is very sad. SIG. I'll be surprised if it's in 2024. Oh, it's 2020, 23. I'm sure it is in here. This is what I'm looking for. I just want to make sure I'm using. Wow. Could it be that it's in a different? Anyways, it appears I don't. This is quite unfortunate and sad actually, because I actually thought I had that data set somewhere here in research. It's very unfortunate. There we go. This is what I wanted. This is quite unfortunate. Apologies for that. I needed to extract this to be a lot easier for us to understand if I use this data set. I'm going to context switch as we are having this discussion, right? So we have this. We typically have a data set. When you have a data set, right? A data set is usually associated with, if you remember our discussion, your typical data set is associated with, it's associated with, this is horrible stuff. I haven't revisited this thing in a long time. And when I'm creating these data sets, I use a lot of very stupid things here, like I import functions. So you notice these things it's like it says it's missing here, but they are formulas, right? So they're pulling data from other spreadsheet files. So it's still loading and it has to recompute a lot of things. There we go, beautiful stuff. This is horrible stuff. I know why I do this, because I'm locking myself in. Is it the moment Google decides to do these stupid things that it does where it switches off services like that, that's it. You're done, right? You're roasted like that. I've lost data like this in the past, but I never learned. Now, colleagues, so we have this data set, right? Student ID attribute, student name attribute, academic year attribute, date of birth, gender, year of study, school, program, right? Now you notice here already, year of study is not an important attribute. Why? Because I know that all of these students are enrolled into this first year course. Yes, there are some that may be repeating, some that may have come from a different school here, but if I think about the problem that I'm attempting to address here, like the solution that I'm implementing, year of study is not important. So your EDA exercise will help you identify these sort of things. Okay, this is what we mean here. I don't know if I don't know if there's going to be a way of doing this. So a number of attributes here, right? What else? School may not be important. Program may not be important because everybody is enrolled into, this is why I hate this sometimes, because everybody will be enrolled into the same program, right? So what we are doing, right, what I'm doing here is I'm showcasing an example of determining important attributes, yeah? And then in terms of attribute types, if you remember our discussion, we realized that data attributes can be categorized into two main clusters. We have categorical attributes. Of course, there are subcategories like that. What the hell is this? And then you have continuous attributes, right? So if we start going through this, I don't know why it's seen as, I don't know if this would work a lot easier here. This thing has frozen, the other one. Crap. And I wanted to use this as an example, just refresh this. So feature importance, and then all of these different attributes here have types. By the way, ethically, all of these things were masked. These are hypothetical names, right? Student ID, if you look at this, you should be able to tell what sort of attribute this is, yeah? Is it? You say you have student ID, and sample attributes are these, right? So as part of the EDA process, you'll be able to identify the sort of attributes you're working with, is it? Right? So you should be able to know what sort of attribute is this, right? What about student name? What sort of attribute is student name, for instance, right? What about quiz one? Yeah. So by determining the different sort of attributes, you want to have a sense of whether this is categorical, right? This is categorical. This is continuous, right? Right? What specific type is a ratio type and stuff like that, right? So this is what we mean by determining the type of data attribute. And this is all important because you will notice that as part of data preparation, a crucial thing that we do, as outlined in lecture series number 3, is we transform the data. We are converting the data into a form that the algorithms, that the estimators are expecting. And it turns out that the way that you convert data from categorical, from ordinal, right, from nominal, is different. The techniques that you use are dependent on the type of data attribute. It's one of the reasons why you have got to determine the attribute associated with each and every one of these things. Guys, I'm going to copy this here, and I'm going to paste it here, so that we have the data here. I don't know if it's probably going to want to paste. That's much better. It will be easy. Otherwise, if I rely on Google Sheets there, things are going to be insane there, right? If you get my drift, colleagues. And what I can do is I can dump this in Playground and just call this the same name as this. Boom. We just say .csv. It's a CSV file anyway, just say it like this. And then I'll save this pipe symbol delimiter, beautiful stuff. Okay, so the key thing here is you have got to determine the different sort of attributes, right? And it gets complex. Again, I want to draw attention to something that I had mentioned, maybe some of you have forgotten. I'll call this 1110 students or something is equal to pd.read CSV, and I know that the SEP here is equal to, I don't know if you remember this here, the SEP here is equal to thing, and then I'll pull this file, playground/that, right? Anyways, what we're saying here is that in our case, we have this complex data, right? Data set rather. How many attributes does this thing have? Well, we can count these is it? We can count this by just converting this into a list, right? Say I treble, and then we can count this, right? Len. And I think we could have done a len. So this data set that we're looking at right now, this has a total of 69 data attributes. So as part of the EDA process, one of the things that you've got to do is for each of these different attributes, right? We can do the usual, we can look for var attribute in here. Just print var attribute. Right? So for each of these here, we have to identify what data type is student ID, student name, academic year, date of birth, gender, year of study, school, program, and stuff like that. And once you do this, it becomes a lot easier for you to figure out what sort of technique you're going to use to transform this data set. Okay? What else do we have to do as part of the EDA process? Well, we will decide, right? Is student name going to be an important attribute? And the techniques that you can use, the simple techniques, I'll showcase them to you just now. There's simple techniques that you can use using pandas, for instance. But that's neither here nor there, I guess. Like for instance, you can say var dot describe, is it? Right? So what this is telling you here is that you already have a sense of, you can have a sense, I guess, I don't know if you can transpose this also. You already have a sense of which of these data sets are numeric, is it? And using the describe function, you can actually kind of like have a sense of the data itself, the numeric data, right? You know, number of observations, what is the average for each of these different numeric attributes. Some of these won't make sense, like academic year is a numeric attribute, but you wouldn't want to perform these descriptive statistics like mean, right? Or count and stuff like, well, maybe count here, but certainly not the mean, if this is making sense. There are other descriptive things that you have here, by the way, descriptive statistics like the standard deviation, the mean value, maximum value, right, and stuff like that. But anyways, that's neither here nor there, right? What else? You want to be able to understand the relationship, right, that exists amongst the different attributes, right? So as part of your EDA process, the techniques that will be able to give you an idea as to whether the influence of date of birth is probably the same as gender or something like that, right? There's a relationship that exists. Yeah, so you determine the relationships. And then you'll be able to identify outliers, right? Is it? One of the things you can do is, when identifying outliers here is you can say, I want to see if there are any sort of outliers associated with the final examination, right? I have the final exam here. Of course, the final exam has now entries. What I can do here is I can say few NA, I can just say drop NA, is it? Instead of few NA, right? Why can I do this? Because I have the luxury of doing this. Like, it's like, how many observations do I have? 457. Well, what if I drop the NAs, right, for this field here? Drop NA or something like that, right? Yeah, instead of having 457, I'll end up with 304, right? Attributes or something like that. But anyway, I won't drop them, I guess. I'll just say, you know, for life to be a lot easier here, I'll just say fill NA, fill it with a 0 or something, right? I think you need to do an in place is equal to true here, so that it modifies the I don't know if this has worked here. I'm just going to say few NA and then just check again this. Like this. Okay, just it fills it by default, right? It fills it. You don't need an in place. Anyways, so you do this and then you can plot this, is it? You can plot this and you do the same thing, import, you know, matplotlib, or you just say from matplotlib import pyplot as plot, right? And then you could say I want to see if I can plot a histogram of this thing here. And you do the usual things we were discussing last time. I put PLT dot hist, is it? I think hist, right? And then I say PLT dot show or something like that. This should work or something like that. And then you have this. Ooh, guys, I don't know what's happening here. Okay. I don't know if we can see outliers here, right? I would say these people, it shows a hard exam here. Okay, it was not a hard exam because what I've done is I've said all of those null values, replace them with a 0, which was a horrible decision here, right? I should have probably just deleted the null entries, okay? So I've plotted a histogram that gives me an idea, right? An idea of the performance of the students, right? You know, so with this, I'll be able to identify outliers, for instance. Anyways, it turns out that when you're performing your EDA exercise, there are certain things that you can do to help you ensure that you do everything that is expected, right? So that you're comprehensive in the exercise itself. So one way of doing this is you can ask what are called leading questions, right? So for instance, questions like, what are the different types of attributes in my data set? What are the different types of attributes in my data set? Well, for me to find out the different types of attributes, I can use Python pandas. I can inspect the data. I can check the columns, right? Oh, I have these columns or something like that, right? So different types of attributes. I can do other interesting things like, I don't want to forget some of these things here. I can do other interesting things like, let me just do dot. Other interesting things like, I don't know if there's an interesting thing that I have forgotten here, transpose, but, so these are fields here, showing it program quiz, school sponsor. I'm looking for there's usually some interesting, attributes that you can use, right? That you can apply on a data frame. I've already showcased, described here. I'm sure I have them as kind of like examples or something like that, but that's hist, insert. Yeah, I don't know if Max, probably not that useful here. Anyway, the key thing here is that there are some kind of like functions that you can use to inspect the data, yeah, to inspect the data. And I'm trying to see if there's anything of use here out of all of these different kind of like functions. The two functions, transpose, truncate. Yeah, I don't know. I mean, maybe you can look at specific attributes like gender, right? And then you can do your value counts or something like that, I guess, right? So that you have an idea. I mean, it's like, I guess an easier way of just trying to have a sense of the categorical attributes, right? It's like the distribution of the different dichotomous values associated with gender here, right? Yeah, anyways, the key thing here is you can ask leading questions. So how many attributes? What are the different types of attributes? Well, I have a total of, I load this into a pandas data frame. I have a total of, dot column. I have a total of 69 attributes, okay? How many observations do I have? 457, right? If this is making sense. Some other questions that you can ask is, how is the data distributed? And this is usually tied to numeric attributes, is it? How is the data spread, for instance? So you can draw histograms, right? To have a sense of whether your data is normally distributed or if it's not normally distributed, right? Is it? Right? What did they tell us in statistics, colleagues? Is this data normally distributed? They told us that your data is, you can do statistical tests here, but there's easier ways of doing this, right? Your data is normally distributed if it forms a bell curve, right? A bell curve. is it? A bell curve. But in our case, we have data here that is not normally distributed, is it? You have something like this, right? And then you have like this, if you notice, right? So it's not a bell curve. So this is not normally distributed. And we know why it's not normally distributed, right? It's because we did a few NA, if this is making sense. Anyhow, what other questions, leading questions can you ask? Is there a correlation between the different attributes, right? And the outcome? You know, there are fancy techniques that you can use here, but the idea behind this is that when you have data like this, right? I'm going to close this here. When you have attributes like this, typically, in this particular problem we're addressing here, there are so-called independent variables, right? Things that will influence the outcome. The outcome we are after here is the performance. So quizzes, tests, and the exam, right? And what you begin to notice is that some of these attributes will have the same effect, is it? So there's a relationship that exists, right? They're the same. If they're the same, it's pointless for you to incorporate them in your model implementation process, ideally. Okay, so this is what we mean when we're saying you ask a question whether there's a correlation that exists amongst the different attributes here. And what are the most important attributes? This is a given here, right? Out of all of these 69 attributes, which ones are important such that we should incorporate them into our model building process, model implementation process, right? Some of these are not important at all. Like, I'll give you an example of nationality. Look at this. When I did gender, right? We have an idea of what gender is important because there's a significant proportion of females, right? Okay, a lot of them are males here, but we see that it's important because there's a mix of both males and females. But observe, if we say we want to check nationality, it's like all of them are Zambians but one, right? So guess what? Nationality is not important. It's not an important attribute. It's just one of those trivial ways, simple ways of trying to identify which attributes are important. Usually you'd be graphing these things, by the way, right? You wouldn't really be doing what I'm doing here. So you'd be doing things like group by or something, right? This group by nationality or something like that. And no, it's a nationality dot size or something like that. I don't know if this is size. Then dot plot or something. I think. Dot plot. I'm sure this will not really work that well here because it just plotted a default thing, but I want to plot kind is equal to by h or something like that. That's much better, right? So this, like, you'd actually be doing something like this, right? Visuals and not text, because whereas this example I'm showcasing here is quite intuitive. I can see here that most of them are Zambians. There's only one student with a resident status. It's like, this is not important, right? I don't know if this is making sense to people here. But also, what else is there, guys, colleagues? Dot columns. We can check what else here. School may not be important, right? School may not be important. I know school is not important because all of them are in the same school, right? But what we know is that something like sponsor may be important. Why? Because we know that students, okay, we can check here. This is why we're doing the EDA process anyway. But you'll notice that sponsor is somewhat important because we have people that are related members of staff, right? So they have those waivers. It's these and these. They're supposed to be grouped together here. Tuition waiver and those benefits, I think, are the same here. There are self-sponsored students. There are those that are fully sponsored by the government. Those that maybe on 75% and stuff like that, right? So we see that this is an important attribute. And of course, you know, as a way of doing data preparation, you'd make some of these things. You notice here that tuition waiver dependence is probably the same as user benefits or beneficiaries, right? This GRZ 75% is the same as this GRZ 75% odd. So you'd make these two. You'd make these two ideally, right? You can do a map, dot map, and stuff. I don't know if there's any other kind of field that is of interest here in terms of attributes, really, but you get the point, right? Other leading questions that you ask are things like, what must we do to the data, right? That to the attributes that have missing values. And I already showed the question, is it? I mean, I already showed an example here where I realized that exam, right? Exam had final examination. It had now values. The same applies to test 4 or makeup test, because not everybody writes a makeup test. You notice that there are students that have now values associated with makeup tests. So the question is, what do you do to these now values, right? So the EDA exercise will help you answer this question. So you look at this and you notice, oh, well, I don't know how many entries here will be now, right? Dot is now something. Is NA. Beautiful. I'll do is NA and then I can use this as a thing here like this. So this is showing me that this is insane here. What this is showing me is that out of the data that I have, right, 402 observations have now entries for the makeup test. Now, it's like, what proportion are now for makeup test? Well, the proportion is this. Is it this times 100 or something? So it's like 87% of my data set has now entries for the makeup test. What do I do to those entries? And if you understand the data, you realize, well, a makeup test is, not everybody writes a makeup test. By the way, that's a deferred test, right? So if you're unable to write a test, you request for a deferred test or something. The naming is wrong there, right? So you decide that particular case. Anyway, and then the data sets have outliers or something. Now, what's important here, colleagues, is that to appreciate that the best approach or the most effective approach to you performing your exploratory data analysis exercise is to use a graphical approach where you're using graphs, right, to summarize data. Of course, you can also use a more traditional approach where you just summarize your data by creating pivots, so you group the data, which is what I was doing when I was using a group by function, right? But the ideal thing to do is you visualize this data. And you don't want to sit here and think, right? You have 69 attributes. What is better? You just figure out a way of visualizing all these different attributes, or you start summarizing them, right? All of these different attributes here, right? So graphical approach is appropriate. You know, but of course you can use summary tables. So what you typically do is you use, those different types of graphs, yeah, that we briefly looked at talking about matplotlib when we had a general introduction to matplotlib, but also the graphs that were introduced to you in your elementary, is it introduction to computers course you did in first year, whatever program you did, right? They taught you how to use Microsoft Excel, how you create those graphs. This is exactly what we're talking about. But it turns out that specific types of visualizations are appropriate for specific types of data types. Remember, we said we have what sort of data types? Categorical and continuous data. For categorical data, we have dichotomous attributes, nominal attributes, ordinal attributes, continuous attributes, interval data, ratio data. There are specific types of visualizations that are appropriate for different types of data types. Like, for instance, when you are dealing with categories of information, categorical data, your best approach is to use a bar plot. And I know what you're saying, oh, Lighton, but even a pie chart. I don't know, right? I guess when you're working with dichotomous attributes, yes, right? But usually if you read up on the science behind these different types of visualizations, they will tell you that pie charts are horrible, right? They are horrible visualizations. They make it insanely difficult for you to make sense of what is going on. What I mean here, colleagues, is that I could have chosen to say, instead of doing this for sponsor, instead of doing plot kind is equal to bar plot, so that I have something like this, plot.show, I guess. Instead of having something like this, I could have chosen, colleagues, to say, I'm going to clip this out, colleagues, sorry about that. I'll clip this out here so that it's a lot easier for us to compare. Instead of, get rid of this, instead of doing this, I could have chosen, so, well, who left you in charge, Lighton, to say bar plots are better? And by the way, I like horizontal bar plots because of the space. What I could have done is I could have just drawn a bar plot, is it? Right? This normal bar plot like this. It's one and the same thing. I'm just going to clip it out as well so that, I don't know, so that it's a lot easier to make sense out of what is happening. We can compare the different visualizations. And really, nobody's going to take you to the police to say, why did you use a pie chart, right? If you think it's appropriate, hey, by all means use it, right? But when you're dealing with a lot of data, you'll notice that it becomes difficult here. So if you say pie, and then you say plot.show, it's tricky, right? Beautiful. You see this? You see why I was saying this is horrible? It's like when you're dealing with categories of data, especially nominal attributes, you are better off using bar plots, for instance, and not a pie chart like this, right? In fact, if I were to ask you here right now, right, which one is better, this or this or this? Which one gives you a better idea of how your data is clustered? It's obviously bar plots, right? Because if you look at the pie chart here, there are these segments, these categories that have significantly smaller quantities of data that make it insanely difficult for you to have a sense of what is happening there, you know. But anyways, so these are just guidelines where we're saying you use bar plots for this. When you're dealing with continuous data, most instances you'd plot line plots, right? Line plots. Like for instance, if you want to check the relationship, if you wanted to plot, I can choose to plot what? Here, this data. I don't know. I can have average values, right? I can plot average values. I don't know. Maybe not. No, we're wasting time here. But I can plot average values of scores, right? I can say I want to, guys, I can plot year of study, because academic year rather. Is it? I'm going to do this here. And I could group these things by this and I don't know. I want to showcase an example of a line plot, right? I can maybe check to see if I can group these by it's supposed to be like this here, I think, right? Dot is a part where you do a DIR or something like that. But you get the point here. Instead of the size, I wanted to get I wanted to see if I could aggregate them in a certain way here, right? This is a dot aggregate. Then if this is the aggregate function here, but I wanted to, yeah, I'm going to get mean here, guys. You know, I'm going to say, I don't know if this will work, dot mean. No. I guess maybe it's dot mean academic or something like that. Yeah. Beautiful, right? I guess this will work. Yeah, but I should have, so I'm getting the mean values by academic year. Anyway, so what I can do is when I get the mean values by academic year for all these different numeric attributes, I can then plot, right? Maybe just plot a graph that showcases, I wanted to showcase something like, you're plotting a graph that showcases for each academic year here, 2019 here, for each academic year, 2019 here, 2020 here, 2021 here, and then you're trying to plot against the average score. So what we're saying is we can use a line plot, right? Maybe a line plot or something like that. Anyways, the key thing here is I just wanted to highlight the fact that you can use a line plot when you're dealing with continuous data and also things like a histogram. Now, these are by no means comprehensive visualizations. You know, the onus is on you to try and figure out what works best for you. In some instances, you may want to do crazy things like we did. I think it would be nice here because we're discussing this data set. I may as well showcase to you I mean showcase, you know, guys, I don't know. GitHub does this very strange thing here where they, anyway, this is all over, right? This is all over, all these different applications. In fact, they've started doing these things in more interesting ways now. Back with that, more interesting ways now. I've seen it happen. I wanted to showcase Sigya. This. Okay, so I'm just going to go to, I hope there's not a lot of stuff in here because it's a LaTeX, it's a LaTeX, it's created using LaTeX, and so I'll have to start recompiling things, but I'm pretty sure there's a PDF document. What I want to showcase is the fact that the graphical approach that you're using here can actually be a bit more sophisticated, right? You don't necessarily have got to restrict yourself with working with my God, really? Oh, it's there, paper. Right, so these things here can be, I mean, you can use group bar plots like this, right? This is usually better, right? Give you a sense, right, of the performance here, is it? Number of students that got, we see here that the performance, if you look at the years from 2017, 2018, 2019, 2020, 2021, because UNZA academic years is always the year before and the current one, is it? Like this academic year is 2025/2026. So this 2017 means students that were enrolled into this course in 2018. And you can notice here that the performance from a lot of these students was quite, it was not nice, is it? Grades were clustering between C and C+. So you already have an idea here, right? You know? The proportion of people that got C's and C+s was actually a lot more in 2017. But the explanation here is simple, right? There were a lot more students in 2018. But anyways, so you can have these sort of graphs, right? This is part of your EDA process. You can have sophisticated things like this. I mean, these are all histograms, quite right, but they've been created in such a way that each academic year kind of like presents results. Each academic year is presenting results for all the different assessments, so that you have a sense of where the problem, which assessment was more problematic in which academic year, right? Perhaps it would be confusing here, say you have a lot of assessments here and stuff like that, you know? Or you can do things like this, right? You have like some kind of a heat map. What I'm doing here is I'm just plotting using a Likert scale, right? I don't know if it's confusing here, but to the right here is the extreme end of the Likert scale, 1 to 5 here. So the extreme right here are things that strongly agree or something, and then to the left is strongly disagree, right? And then you kind of like have this visualization here. You can also use a scatter plot, right, for some data, you know. So if I wanted to, and the thing about the scatter plot here, you want to be very careful here, is it? I could create a scatter plot based on, in this particular case, I was creating a scatter plot on hits on Moodle versus exam score. So in essence, trying to have a sense of, based on how often students were accessing Moodle, what was the performance like, right? Do we see, and this is usually a nice way of trying to check a correlation, right? Do we see a sort of situation where those that accessed Moodle infrequently are performing poorly, right? They are below 40 somewhere here, is it? Or does this not matter? Or something like that. But you notice there's a correlation, is it, between engagement, which is accessing Moodle, and your performance, right? These students that are in here, this cluster here, these were accessing Moodle less than, somewhere around 60 times or less than 60 or something in a given year. And that's not a lot, right? Your interaction has got to be somewhat more than that. But that's neither here nor there. Anyways, the key thing, colleagues, is that visuals are important, right? That's the thing here. Now, in the notebook that I'm going to share, I guess, I am going to provide you with notebook number 3. What you notice in this notebook, colleagues, is that, if I can zoom in here. I don't know if there's an easier way of zooming in here, but what you notice in here, this is all about the exploratory data analysis phase, and what I'm doing is I'm using a series of data sets in here. The way I've created this data set is I've created it in such a way that we are incorporating the things that we discussed before, is it? Pre-processing and all those things, right? And then I have a series of data sets. Data set number 1 is the one I was showcasing right now. Students at risk of failing. And so we go through a systematic process where we identify the attributes for some aspect of the data. Because remember, at the very beginning, I'd mentioned to you guys that this data set with 69 attributes is constructed from information coming in from where? Sources of data. SIS, there's a survey, self-administered survey. There's assessment scores, right? So a whole range of things. So what I'm doing here is I may be using data sets before they are merged. Not I may, actually, this is what I was doing. So in this particular example here, I'm showcasing a data set associated with the survey itself, right? And the survey only had, I guess it's 13 attributes or something, right? Data attributes, these are the ones here, yeah? So we go through a systematic process where we're exploring the data, using cell magics, and then I showcase. It's like I'm expanding upon the things we've already done here. I'm showcasing how you're creating your data frame, which is trivial stuff. You know, how you clean it up. You're renaming certain fields that don't make really a lot of sense. And until you get to a stage where you start your EDA process, right? You inspect your data frame in this particular case. Yeah. Just try and see if I can scroll. So one would argue that part of what I'm doing here, right, when I'm inspecting the data frame is I am doing the EDA process, right? I'm taking advantage of inbuilt pandas functions. So I'm checking the number of columns, right, using the len built-in function in Python, right, by accessing this column property in my data frame, right? And then I'm using again the len function to count the number of observations, right? In other words, the number of records, 159. And then something else I'm doing is I'm using those functions we introduced where I have a lot of data, but I want to inspect some observations, not all of them, but some observations. What do? I have a lot of data. Well, I can use the head function. And if you remember, we said the head function only returns by default 10, right? Entries. 10 entries, right? Well, 5, sorry, not 10. 1, 2, 3, 4, 5, right? Samples. And if you remember these dots here, the ellipses here signal that there's more data here. So what you can do is you can take advantage of the transpose, right, function, uppercase T here, so that you convert your rows into columns and your columns into rows so that you can see all the columns here. It's just that the what do you call this? My Quake, the application I'm using here is too squished, right? And I've messed up the font size here, so these things are not properly presented. But if you do this in Google Colab, you can notice once you transpose that you are flipping so that you see the columns as rows here, right? And usually, I find this to be quite useful myself. And then you can have your samples here, so that you have an idea of the data you're working with. Right, and then tail does the opposite of head, is it? You're looking at the last n records. In this particular case, I want to see the last 3 records. These are the ones here, right? What else? Right, using the dot column, I have a sense of the attributes, and I list all the attributes, and then I can figure out what these attributes are, is it? I see that, and I know what these attributes are here by looking at these samples, right? Timestamp, isn't this a date? This is a time. Date, time, okay? Student name, alphanumeric here, right? It's a hashed version of the name or something. And then the student ID. This is wrong, by the way. I swapped off the column names. It's supposed to be student ID and the student name here. Student name here, right? Textual content or categorical attribute, nominal attribute here, is it? Hometown, right? Categorical attribute. Minor program, categorical. Minor program motivation, textual content, right? Which can be, numeric or categorical something. Categorical, right? Did you do computer studies? Yes or no? This is dichotomous. Have you had some training in computers? Yes or no? Dichotomous, right? Computer training type, typing and stuff. This is textual content. How much experience do you have with computers? Oh, 1 to 2. But for some of these, you may not really know exactly what you're working with until you play around with the data. So observe. If I want to check experience with computers, I know it's somewhere here. Survey experience with computers, which is here. So I'll come here and I would say, I want to see what is in here, right? I want to see what is in here. And what I can do is I can do a set, is it? I can cast it into a set and then also cast it into a list here. And then I see here that it's actually a restricted set, right? 1 to 2 more than 5, less than 1. This is now entries. 3 to 5 and no experience at all. What is this? An ordinal attribute, So anyways, the key thing here about what we are doing is we have got to figure out of these 13 attributes, what data type are they? Timestamp, date. Student name, I'm saying it's text here, but it could be, categorical or something. Student ID, alphanumeric. Hometown, text, or categorical, I would argue. But I think we say text here because they observe. Oh, wow. Hometown, where is this? I can't find survey. Looks like suburb here. If you look at this, if we try and check it, like we did before, right? I'll just get this, and then I will get a set here, right? I'll cast it into a set and then convert it into a list. I like lists myself, like this. And you notice here that, wait a minute, these people, and in fact what I can do is I can do for var hometown in here. Print var hometown or something like that, I don't know. Hometown. What you begin to notice is that they were actually specifying these things in different ways or something, right? Somebody just write the suburb, state lodge. Somebody just says Lusaka. You know, some people are putting Chilanga, Koma Lusaka. If you think about this, another sort of thing about what this is you'd say this is, at least a decision I made is, or we made is, this is textual content, right? Because there's no predefined structure. The survey itself told the students, so when you're specifying where you are from, you specify the suburb, / town, / province. And the instructions are quite clear in a survey. But what you begin to notice is when you're dealing with human beings here, if you've built applications that collect data, you notice that human beings will not always follow the rules. The way you force them to follow rules is they choose from a restricted set. The moment you tell them, type whatever it is you want, you have this chaos here. You know, so there are smart ways in which you can kind of like figure out, you know, we want to just extract the first part, or just the second part, or just the last part, or something like that. So we kind of identified this data attribute as being text, right? So anyways, the key thing here is, one of the things you're doing as part of exploratory data analysis is you're determining the attribute type, right? If this is making sense here. And then what I have here is the things we're discussing, where we are coming up with a plan on how we are going to pre-process some of these data attributes, right? If that makes sense here, I guess we can skip some of these things or something, right? I don't know if this is making sense here. I'm going to scroll down a little. Let me just zoom in, zoom out or something. I want to scroll down to a different data set to showcase the fact that the things that you do don't necessarily have got to be the same as what I have in here. It's all contextual, right? How you visualize data, how you conduct your EDA process is dependent on the type of data that you're working with. Here's the thing. Imagine you're working with images, right? How do you conduct exploratory data analysis, right? You know, so you'd have to kind of like render the images, for instance. There's methods, by the way, in matplotlib for you to render those images. Okay, so anyways, the key thing here is that somewhere down here, I have different sort of visualizations. I love horizontal bar plots myself. They're also line plots, you know. And then if I scroll all the way here, I'm showcasing how you can visualize text. I'm using a pie chart here for dichotomous attributes, right? It's yes, no, there are two of them. So it's okay to use a pie chart, right? If I scroll down here, text, right? What I'm doing here is, usually what I've done traditionally, if I'm playing around with text and I want to visualize words, I'll use word clouds. And the idea behind this, if you think about it, is you'll be able to see the things that can potentially be stop words, is it? Like in this particular sample data set, words like computers appear often, right? If they appear often, those can be viewed as being irrelevant, if you will. But anyways, so a nice way of visualizing text is you can use your word cloud, if you will, right? A different sort of data set, but also using word cloud. Now, the key thing here is all of this is being done, in our case, is being done by a specific type of package. And the package I'm using is matplotlib. You can use Seaborn, but typically it would be matplotlib. And if you're sitting there and you're asking, well, wait a minute, Lighton, do we always have to use matplotlib? You know, what's so special about matplotlib histogram here? Well, you don't have to, right? In fact, what you can do if you wish, right, if you want, is you can say, well, I prefer to use the things that I am very familiar with. Like, I know Excel so well, right? I'm probably at work, everybody comes to see me when I'm using Excel. I mean, use it if you want to, right? But the problem with that, what is problematic about that is you're building this pipeline, right? This pipeline which is supposed to comprise of all of these 6 stages we're talking about: business understanding, data preparation. The moment you start using things, incorporating things created elsewhere, you're going to mess up your pipeline, right? Reproducibility becomes a bit problematic here. But what I was saying, colleagues, is that what you can do potentially is you could say, I'm going to use Google Sheets. If you're like Lighton and you've invested a lot of time learning how to use Google Sheets, or you use Google Sheets a lot, it's like, I'll use Google Sheets. You can still plot in here, right? You can still do your EDA process exercise. The point here is simple. I am not saying that the EDA exercise should be done using matplotlib. No, right? It's too agnostic, right? What you can do, if you wish, is you can say, I'm going to first of all create, and this is supposed to be insert. I'm going to create, what do they call them? Pivot tables, right? I'll create my pivot tables. So for me to visualize, I don't know who does this, but I'm sure there are people out there who do this. For me to visualize gender, right? I'm going to create my pivot like this, and then just do a count, right? Works, I guess. And then from here, I will set my chart, right? It's better this way, instead of using matplot, instead of using thing. I guess, I don't know, if you want, you can do this, right? It works, but it's just that when you're building this pipeline, think about what you're doing here, right? What we have done right now is, look at this notebook here. We would be building a pipeline. How are we building a pipeline? We're doing it stepwise. How? Somewhere in our notebook will be some notion of business understanding, data understanding, outlining how the data was collected or harvested, data preparation, EDA. What we can do if we're using this sort of approach is somewhere at the bottom here, when we start modeling, we just include a section for modeling, and then we start writing code about the modeling part and stuff like that. But that's neither here nor there. Guys, colleagues, I don't know if there are any thoughts. Maybe I was talking to myself here about this.
Mr. Perry, I don't know if it's just me, but the screen hasn't been moving.
The screen has what?
It hasn't been moving. It's still on. You're still on tab AZ.
Oh, I think it's your
Or on
connection.
that column. AZ.
I think it's your connection.
Or is it?
You want to check your connection? Can somebody confirm? Can you see?
I can see movement myself.
Yeah. Now, colleagues, right? I wanted to mention something here, and I think I won't say where I went here, but you know, some of these things we're doing, and I know some of you do this at work. No, maybe most of you don't actually. You should, if only you were part of our data science program, right? You can audit some of the courses we're going to have next year. Interesting stuff we're doing there. But you know, especially maybe next year actually, because the students that are enrolled in our Master of Computing in Data Science are doing a professional master. So it's coursework for 2 years. And there's some interesting things that they're doing next year. So if your part 2, when you do your research component, if you're going to be doing something that is related to data mining or data science, I highly, highly encourage you to audit the courses next year. You won't be disappointed. Now, a lot of them, right, they're actually doing this in a real-world setting. So we have quite a number of people from Zamtel, I think there's somebody from MTN. We have about 4 from Zamtel, from the same department, which is quite interesting. People from MTN, somebody from Madison, right? So what I want to say is that some of these things we are discussing here, if you haven't really worked in an environment where you've experienced problems that require a solution that is data mining centric, you probably trivialize some of these things we are doing, right? More so because, unfortunately, the examples that I tend to use, or examples that I used online, are simple data sets, right? So the iris data set or something, right? It's not really complex things, but in a real-world setting, you'd be working with not 69 columns, right, or data attributes, hundreds, if not thousands of data attributes. You know, so I must say this. Somebody approached me, there's a fraud-related kind of solution they're wanting to create. Exciting stuff. And I sat there and I'm thinking, if only this thing was not hush-hush, I would have really loved to use this as an example, right? So that people kind of like understand or something like that. Anyways, I don't know if any thoughts or comments about this. What I'm going to do is I'm going to share with you the notebook, colleagues. Okay, the notebook, which is self-explanatory. But I thought before we part ways, we'll just set the stage for our next phase, is it? Because remember, we are saying that we are following the CRISP-DM methodology. We know how to kind of like understand the problem and come up with the objectives and the plan of what we're going to do, right? This is like project management and requirements elicitation. We know how to harvest data, how to collect data. As part of data understanding, we now know what it takes for us to do a so-called exploratory data analysis exercise. We also, as part of data preparation, we learned last time how we clean data, how we pre-process data, right? Now, once you pre-process the data, you've done your ADA process, you pre-process the data. Before you start modeling, what you have got to do is you have got to transform the data. In addition to transforming the data, if you have disparate data sources, you have got to merge data coming in from the different data sources. Case in point is the same example I'm using, right? They have different data sources, SIS, I forgot Moodle, logs, right? You transform the data and you merge. Or if you want, you can harvest the data, you merge the data, after you merge, you transform. It's up to you, right? Doing the same thing here. I personally prefer to, I think the approach I normally take is I merge before I transform, okay? But that's neither here nor there. But the important thing to appreciate here is that after data processing or data cleaning, what you do is you must transform, right, and merge the data. Okay, and a reminder here that it turns out that the data that we're dealing with can be associated with all those different types of attributes, right? It could be images, video, sound or audio. This could be categorical data. The problem I was talking about fraud, it's all about images. It's so exciting, actually. It can be textual content and all those things, right? So the thing here is that it turns out that those data attributes that we had a discussion about, if you remember, they are categorized in a certain way, is it? Yeah? We had a discussion about those different categories. In fact, even these other kind of more evolved data types here can be associated with this restricted set of attributes that we were discussing last time, right? If this is making sense, let me just check here. Okay. Yeah. So anyway, so our interest is to try and figure out exactly how we transform this data, right? And the nice way of thinking about this is we are converting them into numbers. We're simplifying things, but converting them into numbers. It's a nice way of thinking about what transformation is all about. But the correct definition of the transformation process is you are converting the input data into a form that the algorithms or the estimators expect. Okay? The vast majority of algorithms or estimators take in as input numbers, numeric entries. They also produce numbers or numeric entries. Okay? So in other words, what we're doing as part of transformation is we are converting our input variables into numeric equivalents. All of them, right? Or those that you deem important. We get date of birth, it must be converted into a numeric attribute because it's not numeric. We get gender, it must be converted to numeric. We get year of study, first, second, it must be converted to numeric. School, numeric. Everything numeric. However, for entries that are already in numeric form, we do not do anything, ideally, right? Like test scores, or quiz scores here, or exam scores. However, something that is commonly done on numeric entries is you can scale them. Right? So for instance, your scores are between 0 to 100. There are certain problems or certain solutions that will require that you scale them so that a score that lies between 0 to 100 can be scaled to any value that lies between 0 and 1 ideally. Okay, so you can scale. Okay, so simply put here, what we're going to do is we tend to focus on the some of the most commonly used attributes here to try and understand what transformation is all about and why it's important. Okay, so I'll be illustrating exactly how this is done. I'm going to be context switching here. I'll attempt to see if I can context switch. If not, I think maybe we ought to make life a lot easier. Just copy the code or something like that, right? It'd be easier that way, I guess. Right, so for instance, our goal here is when we have a nominal attributes rather, we want each of the labels representing the nominal attributes to be represented into the equivalent numeric form. So we see that there are simple but really effective ways of converting, these different attributes into numeric values. Ordinal, we do the same thing. We want to convert these ordinal labels like on a scale of 1 to 5. Strongly disagree, right? This. We have values that strongly disagree, neutral, agree. We want to convert these into numbers, right? Yeah? These are ordinal attributes. Ratios and interval attributes is already in numeric form. Remember, these are continuous attributes. So what we do is we typically would leave them the way they are. Something else we're going to look at here is how we convert textual content into numbers. You will notice here that there are cheap tricks that people use, right? You just build a frequency table, is it? You look at some piece of text, and then you look at all the text associated with your observations. You get the unique words or terms, and then for each unique word, you look at the observation. You ask yourself, in this observation, the text for this observation, how many words, how many of such terms are in this text, right? So you have a simple frequency table. But usually that's not very useful, which is why people use, fancier techniques like continuous bag of words or something, or TF-IDF. So we're just going to focus on bag of words model here, where we're looking at term frequencies. We can look at TF-IDF as a term frequency in this document frequency, TF-IDF. All right. So we're going to start off by looking at nominal attributes, right? And we'll start off by using examples available in our data set, right? Like minor description. And maybe, this is wrong, by the way, colleagues. I don't know why I did this. A plus, A, B plus, and stuff, these are not nominal attributes. These are ordinal attributes. Okay? So let me see if these are ordinal attributes. But a reminder here that our nominal attributes represent what? Categories, right? A restricted set of categories, right? Where order is not important, if you remember those different characteristics. So if we look at our example here, it's pretty straightforward, right? The minor program, French, English, geography, history, mathematics, civic education. These are classic nominal attributes, right? There are more than 2 categories where order does not matter. But what other attribute do we have? In here, in our data set, var in here. What other ordinal attributes do we have? Sponsor, right? It doesn't, and we know this is a restricted set here because we can convert it into a set and a list. And we see here that we can either have somebody who has a tuition waiver if they are related to a member of staff. They are fully sponsored. They're on 100% government bursary. Unza benefit is just the same as tuition waiver. They can be self-sponsored. They're paying their own fees, tuition fees. Government sponsored is the same as this, right? So we can mix the two. They can be on 75% sponsorship. So this is a restricted set. But it doesn't matter whether you are self-sponsored or you are 100% government sponsorship or you have a tuition waiver, right? Your status is still the same. Order doesn't matter, right? Classic example of a nominal attribute. Okay? What else? We had examples in our data set. We have an example in our data set like, I know nationality only have 2 types here, but if you look at nationality as well, this is a classic example of, there are 2 here. Dichotomous attribute, but a dichotomous attribute is a type of nominal attribute, right? Where the categories are exactly 2, in other words. Yeah? What else here can we choose as a classic nominal attribute? The thing that was a bit messy here, the suburb, right? The town where you come from. In as much as they're a bit messy, it's textual content here, but if you stripped out certain types of entries, you'll notice that a part like the town here can be viewed as a nominal attribute, is it? Odingungu, Kitwe, Livingstone, State Lodge, and all those things, Chipat and stuff like that. Anyways, so it turns out that what you do when you want to convert a nominal attribute into numeric form is you use a technique that's called one-hot encoding, right? And the idea is simple here, right? You get your categories, you transpose them, and then you check which of the transposed entries matches each observation. And this will make sense just now, right? But you transpose ideally. And what I'm going to do here is, for this to make sense, I guess, is we can use I'll use this survey minor thing here. But also, you see now, guys, colleagues, I don't know if the survey minor thing is going to work here. I'll use minor classification, which is here. So no, this minor program. Okay, so what I'm going to do here is I'm going to copy it. Boom. And then, it will be a lot easier if I copy not just I'll copy this field, and I also need the name, I guess, and the student ID to be easier that way. And then I'll paste these here, modify this slightly. Oof. I don't know why this is not working. Oh my goodness. You know, I know they're already aligned here, so I'm just gonna paste this here. They're already aligned. I don't have to worry about the fact, oh, they're misaligned and stuff like that. And it doesn't matter if they're misaligned or not. So imagine we have this field, is it? We have this field, and we know that this field here is made up of categorical attributes, right? How do we know? Well, we know this because we can actually we can actually get these things here, right? These already copy pasted and stuff. It's already copy pasted here. In fact, I should have. I don't know why I'm even doing this here, but I'll call this field or something, and then I'll just say concatenate. Concatenate this with this. It'll be easier that way. And then I'll just get everything all the way up to the bottom somewhere here. Like that. And then instead of doing a text join on this column, I'll get what? I will get D2 to C, D2 to D458 here, so that I have this, right? And then what I'm going to do here is I'm going to say, observe, what I'm saying here is if I get that field, right? What I have here is, I'll just say minus. I have this, right? Is it this thing here? Now, if you look at the var minus thing that I have here, this, we know that this comprises of nominal attributes, because if we get, because this is a list here, if convert it into a set, this is horrible. I didn't, I need to, instead of concatenating this, I will need this, I'll need this to be equal to, I don't know why this is not working here. Delimiter. I don't know if this is, I don't know if my text join is working just fine here. Text join. I don't know if I need to do this with, there we go, beautiful. So if I need that, it's horrible sometimes. var minus, right? I'm just going to overwrite what is there, var minus like this, right? You see, I have var minus here, right? It turns out that var minus, currently with the list here, I have all those 457 entries, right? But what I can do is I can say, because I know the set has a property where entries are unique, I can get a restricted set of entries. Is it? Which are these? Right? So there's LTC, there's history, there's religious education, there's geography, I don't know, physical education, I guess, PES, unclassified, civic education and stuff. So the idea behind hot encoding is you identify the, I'll cut this out because it's served its purpose here. But why is this not working? Delete, thank you. You identify the column that has the nominal attributes, you get the unique entries, and then you transpose them here. Okay? So in our case, our unique entries are these. There's LTC. It's like you get LTC, it will be a field here. Getting? You get history, it will be a field here. Here. You get religious studies, it's going to be a field here. Okay? You get all of these unique entries. I'm going to get all of them so that this makes sense here. It's okay. You get geography, field here. PES, field here. Right? Unclassified and civic education. I mean, I could have simplified this here, but civic education, but copy pasting, I guess, is okay. Already ran out of time anyway, but I get civic education, field here. I'm going to copy it like this. Civic education, field here. Mathematics, field here. Maybe I can stop right here, colleagues. I don't know. Maybe not. Mathematics, field here. We might as well do this exercise. CSE. CSE. ADS. English and French, or something like that. And so you, when you run hot in code, right? What you do is you're like transposing the unique entries, right? So you get the unique set of all nominal attributes. There could be duplicates if you look at your entire set of observations, but you transpose the unique entries. If that makes sense here. And then what you do, afterwards is you start checking, right? You start checking your observations for each observation. For each observation, how do you, for each observation, you ask yourself, which of these newly derived fields here, or columns, is associated with the entry for that observation. So in this particular case, it's religious education. Where you have a religious education, you one-hot encode it, right? You add a 1. Everything else is a 0. So if you look at this person, this Elijah Temba or something, right? It's a hypothetical name here. What you do is you come here and you say, is this religious education equal to LTC or something? If it's not, it's a 0. If it is, it's a 1. And really, you can make this, you use an if condition here. Is it if? We can use an if condition here to kind of like quickly do these things here, right? If this is equal to this, then 0. 1, otherwise 0. Is it? Done. Right? And what I'm going to do here is I'm just going to mark this thing fixed here. Right? So that I just add, this thing is just going to evolve like this. Right? So in other words, for this person called Elijah Temba or something, you will notice here that the only place where you are one-hot encoding is where the religious education is equal to religious education. If that is making sense. You do the same thing here, right? You do the same thing here, right? We'll just call this 3, I guess. I don't know. Ooh. 3 here, right? So I'm checking here. Is this religious education equal to this? But this is religious education, so it's going to be the same as well, is it? If this, I think it is going to be the same. So you're doing this. You're one-hot encoding, right? CSE is slightly different from the previous 2. So you come here, you're doing the same thing, you're checking, right? Is this equal to this? If not, 0, right? If it is, it's a 1. So everything where the value, the odd value is not equal to the newly derived field is going to be 0. If it is equal, it's going to be a 1. You are one-hot encoding. This is all you do really with one-hot encoding. And it's quite trivial really, if that makes sense. Okay, so if you look at our example that I have in my slides here, you will notice here that we've one hot encoded entries here where the entry for the observation matches the column name, right? English. Okay, missing data is excluded here. English. Civic education is the one here. English. Mathematics is at the far end here. If this is making sense, I don't know if people have thoughts about what is going on here. Anyhow, that's that. And then what you notice in the slides, what we are doing is so there's a couple of ways of doing this, right? You can use one hot encoder or something. I feel that's a more complicated way of doing it, right? In an ideal case, what you would be doing when you're one hot encoding, observe, we're going to go to this, and we have this field here, right? Called it's not var minus here. I don't know. It's not minus here. Columns. It's supposed to be. I don't want to use the one that is coming from. I'm trying to avoid using minor classification. Is what I wanted. This is the one we're using. So the idea is you want one hot encode this, and it turns out that this process is actually quite trivial, right? There's a couple of ways you can do this. You can use scikit-learn. There's one hot encoder class you can use, but also you can use Python pandas. So Python pandas, if you go and import pandas as PD, you have this function here, get dummies, right? So what get dummies does is you can feed it a series, right, from a data frame to one hot encode, and then what it's going to return is the one hot encoded entries associated with that particular column, right? So in other words, the way that we would one hot encode this is, Jesus Christ, it's not even classification, colleagues. It's not classification. Classification is different. It's minor program. Thank you. Right? So all you do is you say, I'm going to get pandas, PD. I've imported pandas, and then I'm just going to get the get dummies, right, function. And in here, I'm going to feed it this. So what I would have done here, ladies and gentlemen, is I would have one hot encoded all of these different entries. If this is making sense. I don't know if this is making sense for people. And what you do then is you'd obviously have to figure out a way of concatenating these things. And I'm simplifying this because ideally you have to rename these fields, right? But let's do this and see what's going to happen here. What we can then do is, if you remember our Python functions that we looked at, but we may not have done this here, but there should be this merge or concatenate. We can concatenate fields, is it? Right? We can combine the two different things here, because observe, when I do pd.getDummies, what is returned is a data frame. If what is returned is a data frame, observe, it's a data frame that has the same, kind of like the same shape as the original one. The original one is this, right? If I get the shape of this, I have the same number of observations. It's like they are aligned, right? The row 0 for here is going to be row 0 for here. The columns are different here, right? There are 13, there are 69 here. So what I can do is I can merge this, right? The one hot encoded entry, which is pd.getDummies, and usually I would start with, I want to start with var underbar ICT this. So I'll do pd.concatenate. I'll concatenate the original data frame and the one that I'm going to derive here, which is this, the one hot encoded one, right? this thing here, boom. And then what do? I want to concatenate this, but where is it now? I want to, what is happening here? I want to concatenate this in such a way that you see here, there's I'm just going to do a help pd.concatenate concat. See, there we go. See that, right? Oh, I know this is a series here, but concatenate here, right? The syntax is like this. So syntax is a bit off here. So I'm going to do a pd.concatenate, but what I'm going to do is change the syntax so it's like so. Square bracket here, square bracket at the beginning. It also major, I guess, right? There's still something that is off, and I don't know what it is here. I'm going to do again concatenate, boom, square bracket, var ICT, comma, pd.get that. Oh, I'm going to copy this now. pd.get dummies. Oh, yeah, you see now. pd.get dummies. This is for the get dummies part here, right? And then, yeah, there we go. But we need to explicitly specify that this is column-wise, right? So the axis is going to be equal to 1. Right? So what we've done here, and I'm going to create this var underbar ICT students. I'll call this merged. Let's go to this. So if I check this now, observe, if I check the columns that are associated with this merged, the things that have one hot encoded here are added as columns, right? So there's ADS, there's civic education, and all those things. So I have one hot encoded them. And in fact, true to that, ladies and gentlemen, colleagues, if I attempt to get this and say I want to get the very first entry, and I'm going to transpose it, right? Not that useful here. You'll notice that the ones that I've transposed, because when you transpose them, it's a 1 or a 0, but the default pandas here is showcasing that false is a 0, is it? True is a 1, right? False is a 0. So these are actually one hot encoded. Okay, if this is making sense. Now, there's something interesting here, right? The fact that, observe, we're moving from a state where we've preprocessed the information. When we preprocess the information, right, we have 69 attributes. When we just one hot encode one categorical attribute, observe what happens. Right? The dimension or the dimensionality is increasing, right? Because what we have done is we've gotten the unique entries. It's like 69 plus this by minor program or something like that. It's 69 plus, we get unique entries of this, and then we get the length. So we are saying we're getting 69 plus 13, right? So we're going to have 82. If this is making sense, and it's something you want to be wary about, right? The fact that as you are transforming, your original data frame is actually going to be increasing in size, right? The shape is going to be increasing, at least in terms of the columns, right? And the interesting thing about what we are doing right now is there are a series of other things, right? That there are a series of other fields, is it? That are categorical or are nominal and would have to be like sponsor, for instance. So we're going to go back to sponsor here and do something like here and go to sponsor, right? And we check how many unique entries do we have in here. We can count them. There are 8. So meaning that if we one hot encode sponsor, we are then going to have 82 plus 8, will be 90. The data frame is now going to have 90 columns. And it's not so much of an issue, right? Because you are transforming these things with the aim of feeding the transformed entries to the model implementation process, right? So what you can do actually is, as you are one-hot encoding, you can remove the things that you've one-hot encoded. If you want, I guess not that it will change anything, is it? Because if I one-hot encode, when I one-hot encode sponsor, it has 8 columns. If I delete the original sponsor, it's like instead of 90, I'll have 89, right? I mean, it's just like, what is that, or something like that. But anyways, so what we can do is we can do this iteratively, or we can combine it and say you can come to this, right? You have this data frame that has the one-hot encoded entries for the miner, and now we want one-hot encode sponsor, right? What we can do is we can do the same thing we're doing there. We can do a pd.getDummies, right? And remember, I'm now going to work with the one that I've merged here. So I'm going to get, or you can work with the original one, nobody cares, right? Because they are aligned anyways. So what you do here is you're going to get pd.getDummies. What are we one-hot encoding? This, but which field are we one-hot encoding? Sponsor, right? So when you one-hot encode sponsor, we're going to have GRZ at 75% and all those things, right? What's the benefits and tuition waiver, whatever, and all those things. And then what we have to do then again is we have got to merge, is it? So we do a concat again, and then we're going to get the original one. This, merge it with pd.getDummies, boom. And then it has to be column-wise, is it? So access is equal to 1. And then we're going to have this. But again, here I can say var ICT merged. I'll call this merged sponsor, something like that. I don't know. Is equal to this. So that when I now check ICT var merged sponsor or something, and I check the columns, I'll now have towards the end the one-hot encoded entries for the sponsor, is it? Right? And these are ordered for you, by the way, right? And classified, okay, GRZ 75, GRZ 75 odd, GRZ fully sponsored, GRZ fully sponsored odd, self-sponsored, tuition waiver, dependence, owns the benefits and stuff like that, right? And if I check the shape here, I will now have 90 or something like that. 89, I don't know why it's 89 here. Something I've missed out, I don't know what it is. There's probably now entry maybe, I don't know what this is. If this is making sense. Anyhow, maybe something else you notice in the code is that if you remember circuit lane, right? So from SK lane, this is a long way up here. SK lane, you can import. Just from import SK lane. Do I not have SK? What the hell is this now? Import SK lane. Okay, it's there. So one of the things that you'll notice is that in SK lane, right? It's a dir here. SK lane. In SK lane, you have things like process. Okay, processing, not process. So SK lane dot processing. If I check in here, what is in here? One of the things I'll have here, if you notice here, binarizer, forget about this, label encoder, probably discuss this here. When you're outputting, if you're building a binary classifier, yes or no, right? You can use a label encoder, right, to encode what a 1 is and what a 0 is or something like that. But surprise, surprise, you see this? There's a one-hot encoder class. So what you can do is you can sklen.preprocessing. We can import, I can import everything, but I'll import one hot encoder or something. I don't know if this is the correct one here. One hot encoder, something like that. And then what you can do is you can, the way you do this, and And the reason why this would make sense is when you're, it turns out that the way the API works is similar to how you'd fit and train things, right? When you're actually working with estimators. It's always nice to know how to, it's always nice to know how to do this here, right? Just do a help sklen.processing. Okay, help one hot encoder. Something. I'm sure there's an example here. There's got to be an example here. It's got to be an example. There we go. There we go. So anyway, so you have to fit, right? You have to fit it. So you're telling one hot encoder how to interpret the values associated with that particular series, right? So you have to first of all fit it. The way you do this is you import one hot encoder, and then you can just say one hot encoder is equal to one hot encoder. I think I can create it, yeah, without really feeding it anything, the things that we had in the example here. And then using this instance of one hot encoder, you can then fit and transform, right? So fit and transform a given field. So in this particular case, maybe one of the things we might be interested in fitting and transforming is, we can start with the original one. Is it var ICT dot minor program or something like that? I want to use dot here. What I'm going to do is this. Is it minor program or prog? Okay, we can check here, I guess. Columns. I'm looking for this. I'm looking for just before where we have the category, not category, just before where we have, but it's here. Why is it not working here? Oh, string, right? Right. So what I've done here is that I've created a sparse matrix which I can then merge as well. If you notice the shape here, right? The shape of this thing here. Same exact value. And so the way scikit-learn works is that it will typically create it will create what's called a sparse matrix, right? For efficiency reasons, right? So you won't really you don't necessarily have direct access to what you'd have created here. But of course, when you feed this to an estimator, you're able to interpret what is in here. You would only be able to, let me showcase something here. I'll call this minus is equal to this. You only be able to gain access to these things. You can't see like what's in the space matrix, right? What you can do, however, is you can extract certain things here, and I believe I've already fit it actually. So I can do var this dot there we go dot get feature names out, I think. Yeah. So I have these things here. So you notice, and I guess one of the interesting things about about using this is you notice that the names are renamed for you. Yeah, I don't know if you notice this. The names are they're okay. They're not really renamed for you. You still need to rename them because they're just prefixed with this, which I think you can do with get dummies as well. You can specify the prefix, I believe, in get dummies. Right? Observe. I don't know if you see what I mean here. the fields, the entries that we had religious studies, we had PES, LTC, we had these things here. Yeah, this thing, what the? We had these things here, LTC, history, when we manually built this, right? Some of them have spaces. But the way the one-hot encoder version works is by default, what it does is it prefixes the original column. Observe, I was one-hot encoding what? This. Right? So when I use the one-hot encoder class or instance, what it will do is all of these different one-hot encoded entries, unique entries here, will be prefixed with the original column name, with an underbar, and stuff like that. If this is making sense. And so anyways, what you do is you fit and transform, we fit and transformed, and then we have our encoded data as well, is it? When we did our fit transform, I created this, right? The sparse matrix. What I can do with this sparse matrix, I can go to my original data frame, which is, I think it's student. I'm going to create this with one-hot encoder minus or something. I don't know if you remember this here, right? And then what I can do here is I can say, I have the data, but what I want to do is I want to create, student observe pd dot we can create a data frame, because this, observe, right, this is a sparse matrix, right? This is a sparse matrix, the thing I've created here, right? This. Now for me to make sense out of this, and if I want to merge it to my original data frame, I've got to convert it into a data frame ideally, right? And then merge it, if you will. I mean, I can append it the way it is, but I think if you want to see what is actually there, what you can do is you could say pd dot is data frame, and I want to create a data frame based on these encoders. The columns are going to be equal to the feature names, right? This, the get feature names here, out. Ooh, I don't know why this is fading. I don't know why this is fading. I'm going to OCH dot get feature names out. I'm trying to figure out a way of converting a sparse matrix into a dense matrix here, and I think I'm lost. Let me just I'm just gonna say scikit-learn sparse matrix to, I'm gonna say data frame or something like that, right? See if this will work. There has to be an easier way of doing this. There has got to be an easier way of doing this. Not that it matters. I want, because you can merge them, is it? You can merge this. It has the same shape. I can merge it with the original data frame, but I feel it's a lot easier. It would be a lot easier for us to understand what is. Come on, really? Why is this thing not coming up here? It's saying recommended, but nothing is popping up. It would be a lot easier for us to understand what is going on if we actually see what is associated with this sparse matrix or something. Oh, I know this is sparse from, okay. So this is what I need here. I'm going to get data frame sparse matrix from sparse matrix. Okay, that's fine. Which I guess would be fine. I don't know. Minus, right? And according to this, what we have to do is just do this. Beautiful. Right? Of course, I mean, you have to do fancy things here, like make sure that these names here, right? This 01 and stuff here conforms to, and I imagine this probably has, it may have an option where you can specify. There we go, the columns, right? This is what I needed, because it doesn't make sense for you to. It wouldn't make sense for you to merge. Remember, what we want to do is we want to merge this, what is here, these with this newly created one hot encoded, this newly created one hot encoded columns here. But the headers here, they have 0, 1, 2 and stuff because of how we did this. So you have like columns, and then you're going to have according to this, you need var this, right? Get feature names out, like that. Beautiful. So we would have something like this, is it? So in other words, the newly created thing is going to be this, right? With the actual zeros and ones. And so what we'll then do is we'll do the same things we did before, where we are saying we need to create a new column. This, I'm lost now. I'm going to call this lost one or something. Is equal to this original column, pd.concat. Remember what we were doing, pd.concatenate, right? Original column, which is this, comma, this newly created data frame here, which was previously sparse matrix, but because we wanted to understand what's happening, and then axis is equal to 1 or something like that. So now this lost one here is going to be the same as the original one we created using get dummies, is it? Still 82 columns, right? But this time around, if we check the columns, you notice that they've already been prefixed with a minor program underbar. And true to that, really, if we want to check which ones are English, we can splice out the English minors, right? I can get this, is it? And check which ones are English, right? So the one at ILOC 3 is an English minor, and the one at ILOC 4 or location 554. So I can actually check these, right? And just say, well, I'm going to check, right? var underbar ICICT lost one dot ILOC, right? This, what is there? And then I can transpose. But you see them at the end here. Of course, some of them, you can't kind of see everything here, right? This is why you have this ellipse here. But you can notice here, these things here, right? Guys, I don't know. But maybe we can check which one is religious education. Woo. Where is religious education? I don't know if there's any religious education. I'm going to check here. Good people. And I want to see which one is religious education so that we can kind of see it or something together, I think, if this makes sense. I'm looking for religious education. It's a pope here. It's a scan. I suppose so. Okay, so I see that religious education is the one at ILOC 1 and ILOC 0, right? So what I can do is I can get ILOC 1 or 0. And you see here, religious education as a 1, right? So I have one hot encoded. But the key thing here is that you want to just understand exactly how this one hot encoding works, which is trivial, you know. And then there's obviously something that I like using as an example, right? It's like we have something else, colleagues, right? Besides minor, we have an interesting field we call gender, which is a dichotomous attribute, right? This is like, well, dichotomous attributes are a form of nominal attributes, right? We can one hot encode this, quite right. And you are right, we can one hot encode them if we want to, right? But the problem is, it's like, is it really necessary for us to increase the dimensions of what we're working with by 2? Is it really worth it? So that we have F here and M. And then where there's F here, we're going to have 1, 0, right? Where we have M is 0, 1. Where we have we have M is 0, 1, M 0, 1, where we have F 1, 0, where we have M 0, 1, where we have F 1, 0, F, what the, F 1, 0, 1, right? No. F is 1, 0. What? Manually doing this here. F is 1, 0. We have F 1, 0. You understand? But it's like, it's not really necessary for you to do this, right? It works quite all right because technically speaking, dichotomous attributes are a form of nominal attributes, right? They only have a trait such that there are two. There are exactly two of them. You don't have to do this, right? What you can do instead is, and you know the answer here already. When you're working with binary values, wherever we have, we'll call this new gender. What the hell is this? We'll call this new gender, right? New gender. It's like, well, if you have new gender like this, where there's F, we'll just choose, right? A female will give a female 1, male is 0, male 0, male 0, right? So in fact, what you're doing here is you're saying if this is equal to F, then 1, otherwise 0. Done. If this is equal to F, otherwise 0. So what I'm trying to say is with dichotomous attributes, it's a lot easier because all you do is you just flip the bits, right? You choose. It's either one, right? You just choose. I'll choose female to be 1. Everywhere where there's female, there's a 1. So you notice here that you have two options, right? For the dichotomous attributes, it's usually a lot easier to just do an encoding, label encoder for this. It's easier that way. In fact, you can do it programmatically, you just write a function, right? Or you just replace, in your pandas data frame. Create new gender. In other words, what I'm saying here, you have a couple of things to do here, right? You have gender, observe, we have lost one, right? The lost one has gender, is it? Like this, gender, right? What I can do is I can just create a new function here, fx gender. I'll call this one hot encoder gender or something. And then I'll just say, what the hell is this now? I'll create this. It will take in an input, right? I'll just say if var input is equal to f return 1, else you can do a one-liner, by the way, else 0 here, and then you can come here and just say I want to get var lost or something, right? And then what I'll do is I'll get where there's gender like this, and then I'll just do an apply, right? Like so. fxn gender on hot encoder, done, right? And then what I can do is I can just feed this I can feed this as a new field. So I'll call this ICT lost 1. I'll call this new gender, new underbar gender or something like that is equal to this, right? So that if I now check the lost one here and I check the columns, the very last column is going to be the new gender here. And new gender now has been changed in such a way that I'm going to get new gender here. You have where there's a 1, it's female. In fact, you can check these line by line, side by side, is it? I'll get gender like this, right? Like so. And then just try and see if I can view them side by side so that we prove the naysayers, right? And you can do this as a one line also. There's a couple of ways of kind of doing this. I think it's overkill for you to one hot encode dichotomous attributes, but you can. You don't really have to make the argument of, oh well, dimensionality reduction or something, instead of 2 columns I'll just have 1. It's like these days, right? You have crazy machines here, commodity machines with 40 GB of RAM or something like that, right? If that makes sense here. And a lot of processing power as well. Anyways, so that's nominal attributes, right? Now, guys, see, it's the time here. We don't have to push things here, but we're almost done though. Don't know. Maybe I'll quickly move. So dichotomous attributes, and then remember, our numeric attributes do not have to be transformed, right? Well, what about nominal attributes? I'm going to leave you with a homework maybe for you to play around with. Nominal attributes are categorical attributes where order is important, if you remember. Likert-like scales. How much experience do you have using Python? 0 years experience. No experience, I'm just getting started. 1 or 2 years, right? And all those things. In what wealth quantile are you? I'm extremely poor. I live in abject poverty or something. I'm poor, right? I am, I guess, wealthy, ultra rich, and stuff like that. Order is important. What grade is this? A plus A, B plus B, and stuff. Those are ordinal attributes, right? So I want to leave you guys with. There's an example though in the thing here. I'm going to let you go and look at the example, but observe. sklearn.preprocessing dot, right? Label encoder. Sorry, ordinal, not label. Ordinal encoder. This is what you use. This is what you can use. However, and this is me, this is just personal preference, right? So there's an ordinal encoder. I think it's overkill. I personally prefer to come up with my own implementation, because when you have like these sort of scales, right? You as a person who's creating this program or building this solution has got to come up with a description of what 0 years experience means, 1 to 2 years, right? Typically, you would have weightings. You'd say, imagine, by the way, you're building a solution that is meant to help you filter people during promotions, right? So one of the fields is programming experience. No experience with Python, 1 to 2 years experience, 3 to 5 years, maybe 5 to 10 years. And then you say, well, more than 10 years. What you can do is, internally, because maybe you're building this on behalf of HR, HR will tell you to say, the way we're going to evaluate these people is such that if somebody has no experience, they'll get a score of maybe 1. If it could be 0, but 1, there has to be a score at least, right? If they have 1 to 2 years experience, we'll just give them a weighting of 2. These are weightings, right? 3 to 5, somebody with 3 to 5 years experience are way better than 3 to 5. The thing about the weightings is the gap, right? The difference is not usually the same. So I say, oh, we'll give this maybe a weighting of 5 or something like that, right? What about 5 to 10 years experience? Maybe this is going to be a weighting of 8 or something like that. What about more than 10? We'll give a weighting of 10. So what you can then do is, you can just write a function, right? It's a simple function here that passes through, right? Passes through a scale like this. And then, what is going on here? And then what it does is, list here or something. What it does is it passes through this, and then you write it in such a way that you're creating a map, right? Dictionary map or something, where you see 1 to 2 years, give it the weighting involved. That's it. Or you can write a heuristic. You can use a simple if-else function in this case. Doesn't matter. It's up to you. Or you can create a new kind of dictionary, right? Where you're saying, if you have, and you remember what we did also. But you see now, this is not horrible stuff here. But what you can do is you can say, we're going to create a dictionary here, right? Where 1 to 2, where this 1 to 2 is 2. And then where more than 5 doesn't have, I can do this, guys, I can do this with beginning the small, we follow the order, right? No experience, 1. Oh, there's even a less than 1 year here. I want to change this. Less than 1 year, 2. 1 to 2, 3. Right? You get where this is coming from. And so forth and so forth. So that when you create this dictionary, right? I'll just XP. is equal to, when you create this dictionary, what you can then do is you can do a substitution, right? Where you have no experience, you substitute. I think you should have, I'm tired, I guess. Oh, I don't want to go beyond 21 or something, but I started it. I can go to where there's this survey thing here. And then I can do a map, is it? Can I map? I think I can map here. What can I map this with? I can map this with this Vikes, right? So what I've done is, and if I finish it off here, if I was to finish it off here, I've created a dictionary that does a mapping between those scales. Let's finish this together actually. I'm going to create this. There's 1 to 2, and then there's goodness gracious, 1 to 2, and then there's 3 to 5. I'll still give this 5, right? And then there's Christ, it's supposed to be I don't know how I created a more than, I even created more than 10 here, and then there's this I'll just give it 10 or something, don't matter. So what I can do here is, if you notice, if I do a map here, right, I'm returning a new kind of a result that has a mapping, is it? And what I can do then is I can say, well, I want to create a new field here. I'm going to call this same survey computing experience thing here. I'm running out of words here. Underbar encode or something. That's it. And then if I come here and I check columns, there will be an underbar encoder here. And so what I can then do is check how exactly this thing has been done, right? This, and check if this will work, which should work also. Oopsie. I want it to be alongside this, like so. Right? So you see here, lesson 1 has been mapped to this. Anyways, now when we want to suggest that we just have a kind of like an epilogue kind of thing, not epilogue, but I would want us to just look at the surface of what is remaining. I want us to just spend a little bit of time, a little bit, maybe less than an hour, on how we convert text, and then Saturday, guys, I'm available. I don't know, it will just be for an hour and a half or something, and then I'll gloss over what is remaining just to give us an idea of what we're supposed to cover or something like that. I think we can leave it at that. I don't know, especially that we started late also. That's why I'm suggesting something. I have a prompt indicating that I'm using a wrong account. Ooh, I don't know what that is here. I wanted to find out if there are any thoughts or questions about this. Here's the thing, right? This is mostly elementary stuff when it comes to data mining. Our goal in the course, and this must sink in here, we're trying to appreciate this pipeline, okay? How to systematically work towards a data mining project. And in as much as these are simplistic examples, you notice that there are striking similarities in the things that you do when you're, let's say, working with images, right? Maybe the pre-processing may be different. There won't be any one-hot encoding because you're working with images, right? You just unroll the pixel representations of the images and stuff. It's the same thing as, processing video and all those things, or even text, right? Where you audio where you convert to text first, for instance, and then you play around with the text. But anyway, I want to suggest we can do it right now here. Unless if you choose for us to have a test on Sunday, which I don't know, but we can have in case we choose a test on Sunday, I want to suggest that we just have, I want to close the class in a certain way, not to leave us hanging, if you will. a number of my courses I was teaching this year, they've been left hanging. I was teaching a computer graphics course, and I feel bad here, unfulfilled, if you will. But so I would want us to just wrap up on a certain way here. So I want to suggest, I'll leave it up to you to decide, maybe 18 hours Saturday would be good. Just 18 to 19:30 will be done, I promise. We're not really going to focus on a lot of things. We just finish, we will look at the text processing in detail, and then the other things like evaluation and implementation, we'll just look at the more important aspects, more important things. Okay? Unless there are any questions, I'm going to ask those that are doing AI if you can manage to remain for a minute or two or something, and then yeah. So I'll be waiting for feedback on whether you want us to have the test on Sunday, which I think would be nice, or if you want Monday, where you have to plan at work. You probably tell them I'm leaving early or something, so that you're on campus by 16:30. At least you get stuck in traffic. For those of you that work in town, I think there's some. Yes, there's a question, please.
Yes, actually, the suggestion for Monday, we are also having another test, like as we're doing advanced IT governance, security IT governance. Yes,
You have
we're
a
having
test
a
when?
test on Monday around the same time.
Yeah. Well, I mean, I'm open to moving a test to a different time on Monday, 20 hours to 21 or 21 to 22. No, I'm just joking. But so this is maybe these are the sort of conversations you should have as a team. You can use that as a reason why you are proposing Sunday, right? And then the question then becomes: do we write it at 12, at 13, at 14, at 15, at 16, or at 17? So I'll wait for you to tell me. You have to decide as a group. Yeah. All right. Thank you so much, everybody. We'll see you on Saturday, and then I'll be on the lookout for confirmation on whether it's Sunday or Monday for the test. Probably Sunday, but what time? All right. I'll ask again the people doing AI if you can remain for a minute or two. Thanks. The rest, you are free to leave. Thank you.
Doc, sorry, before we go.
Yes.
Yes, those videos for lecture 4 as well as this one, if you are able to.
The what?
The recorded videos for the lectures, lecture 4 and this one.
Not a problem. I will upload the videos. It shouldn't be a problem. I'll upload them. Yeah.
Okay, thank you.
Thank you. All right, so for colleagues that are doing the AI, right? There's yeah, I was under the impression that that Dr. Banda, we were aware that he had actually started late. I think we need to provide you with a bit of context here, a bit of background. It turns out that